minimizing charisma, maximizing intelligence, shooting someone in the crotch with a cannonball. It's science. I spot up like that.
There they are. I'm not mad. Science needs art and art needs science. They both need each other to function properly.
There are ways to figure out what the paper is really saying.
And then I'm ready to get on Twitter and yell at people about doing their own research on...
Oh, hold on there, sports fan.
Kyle Hill, everybody! He's the next generation of science communicator. I'm going to be too old at a certain point to do those terrible things to my body, and it'll be up to you.
He's got like a lion's mane. This guy's amazing. Kyle Hill.
I'm Boo Rambo.
The universe is indifferent to you. Whether or not you have amazing hair, the universe doesn't care.
How are trees pushing past this pressure limit? Behold, my balls. Now we're getting somewhere, but I still don't think it's worthy of G.R.R. Martin's suspender.
I'm totally right? Close up photos of my frickin' hair? Is that what you all want? No, you don't, weirdos.
Kyle Hill. Is your last name actually Hemsworth? What's going on?
Our resident Thor lookalike?
I prefer Black Friday Chris Hemsworth.
Oh, thank you.
Hey, you know, if you need a haircut... No, of course not! We're not gonna send sharks with frickin' laser beams on their heads to an asteroid. We're gonna nuke it. You don't need Bruce Willis at all. Wrenched. Oh! Headshot! Oh! Kevin, turn on the monitor. Kevin, this transition better work. The blast doors can't. Kevin, turn it on. Kevin. Kevin, call his agent and have them call my agent.
Kyle Hill, happy birthday! Feliz Navidad!
I'm just a biologist. I don't know how this works. This is how you do science. Can I just grab it? Oh. Laws, corollaries. Bye-bye.
I know that global catastrophe isn't the most fun thing to think about all day unless you're me, so...
Are we gonna do some science, bro?
Lasers don't have that much momentum.
That's not how clockwise works.
Don't worry, you can do this even if you are not an AI.
Completes the boundary layer around a person to a dynamic. And I guess it matters what kind of dragon we're talking. Realize here is that the bigger the thing does.
If this kite is completely inaccurate, I'm gonna kill this guy and tell him to his face. You're wrong about physics. Not enough lift force. Oh.
Nuclear metal donut thing with magnetically confined star-like plasma. The radiation flux in here alone is enough to cause instant death.
That's really funny. I like that idea.
Hey, look at me. I'm a streamer. I have a bedroom. We know anything with a decapitation hazard deserves to...
Ooh. Oh, that's good. That's fine.
Put it on PBS. I dare you. Chat, I want to get heady with you right off the bat. Does color exist when you're not looking at it? If a tree falls in a facility somewhere on the hard, cold, metal ground, and no one is there to observe it, does it make a sound? These are the questions we will try to get at today vis-a-vis explaining the Nobel Prize in Physics that was awarded earlier this morning. Hello, and welcome to Office Hours, the live component of the facility where good old Professor Kyle here lets his hair down for an hour or so, opens up the blast doors, and allows all of you, members of the general public, my security team, Jabo and Heather, my staff, everyone here at the facility to come in for about an hour or so. We talk about everything in this week of science. Of course, if you want to continue on this conversation after we talk about the Nobel Prize, I'll be reading your chat the whole time. Or you can join the facility at patreon.com/Kyle Hill to join the facility today, where you can ping me all night and day on Discord. Or, of course, live right now, if you're watching, you can try Super Chat. I can't promise I'll get to all the Super Chats, but I can promise that if I do not get to it, it will all go towards the the nerdy enterprise that is the facility and everything we do here, especially fixing this light. I guess I don't need any more donation. But as I said, today we will be going through the Nobel Prize in Physics. It's all about quantum mechanics. I have a headache, and I have a headache from researching it this morning. So bear with me. I think we can break it down. I even have a notepad, just because I don't want to forget anything, because it's hard. Kalam, first stream, welcome. Storma, Chase, Spiderblood, Death, Billy, Axel Adventure, Rex Wrath. What up, baby? How's your week, Kyle? Says Jackie's highlight videos. Yeah, pretty good. Actually, yeah, yesterday was all right. Rewatched Beetlejuice. Totally holds up. I forgot how fantastic that movie was. Worked out, got a bike ride in. Evening, Kyle. Congrats on your 100th stream. I've watched every single one, says Christopher Rees. I've seen you there. I've seen you. Kyle, share your headache with us. Isn't that just science? Here, I'm gonna share my headache with you. I've been thinking about this way too much. Now it's your problem. In paper form. You should watch Edward Scissorhands. I think tonight we might watch The Thing. Speaking of The Thing, in anticipation of that, and because it's spooky month, right after this stream is live, you'll be automatically redirected to the gaming channel, where we will start our stream of one of my favorite horror games. I don't play many horror games, but one of my favorite horror games of all time, Dead Space 2. Just in time for the new footage and stuff about the remake. And I think it's the best horror game ever made. So we're going to start our excursion aboard a Jovian city, and also some other places that I can't tell you about. Like the super chat I was telling you about, Tibor. Or Tiber. Or Tibor. with an avatar I really hate, because I can hear it in my head. Hey, Budget Thor, I've been watching your videos for years now, but this is the first time I caught you live. Love you and all the work that you do, Tibor. I appreciate it. Trust me. Just we'll get to quantum mechanics in a second. We're easing into it. This is not an easy topic, so we got to ease into it. Have you ever heard of Rocky Flats, Colorado? And if so, is it on the list for an episode of Half-Life Histories? You can also have a smoothie on me. Your friendly neighborhood Uber driver says, fine point. That has been mentioned to me about Half-Life Histories many times. Speaking of which, coming up this week at the facility, I don't know if it's going to be later this weekend, but I think so. I will be bringing you the first So when I went to Chernobyl last year, I kind of did a general 3-part series about what it's like today. I separated that into the power plant itself, Pripyat, the abandoned city, and then going inside the dome, which is the most recent episode. Now I'll be covering some of the smaller stories I found in Chernobyl, and coming up this week or in the next couple of days, whenever, don't rush me, we are doing an explainer, a history, and a fundraiser for the dogs of Chernobyl. That's right. Chernobyl's puppies, and they are adorable, need your help, and we will be exacting that help. Why? Because we can. Look at our hair. Freed once more from the Vodlands, says Sina Mitz. I got some stuff in the... Your hair is as wonderful as always, Kyle, with the 5. Thank you. I will spend that money on conditioner. Taryn with a 20. Hi, I once tried to make a Wikipedia page for you, and you helped. Oh, I remember you. I remember. But it didn't work out because sources were lacking. I do remember. Just thought you deserved an update here. Love the show, says Taryn. Taryn, I do remember us emailing about that. But... yeah, I don't know why they didn't accept official sources. Oh, yeah, we were trying to find my page in my college, right? But we couldn't find it. Before we'll get to it right now, right after Liz with 20. Tiny Human's question this week is, I got to watch Hocus Pocus, and they lit a candle with a black flame. My mom said you can add different chemistry to make fire burn different colors. What chemical burns black? If you set electronics on fire, you can get some really weird looking smoke. And your mom is correct. Different chemicals, when they react with oxygen and they oxidize and they produce an exothermic reaction. That means exo, outside, and thermic, heat. They produce heat outside of themselves rather than taking in heat, endo, inside, endothermic. I don't know what chemical specifically is black, but I know basically blackish is possible, like tire fires, for example, like the rubber in tires. Have you thought about a show, Salt Batteries, about salt batteries and similar storage devices as Abraxas with the 20? Different kinds of nuclear reactors we can definitely look into in the near future. But speaking of amazing things that happened in the past that are advancing our future, we got to talk about today's Nobel Prize. I don't know why I said it like that. So, today's Nobel Prize. Woo! Hello there, time to sleep here. I'm in France. Cool. Nice. So, as I opened with in the chat, does color exist when you're not looking at it? That is to say, do measurements and aspects of the universe exist when they're not being observed? By which I ask a further scientific point. Are all the results of all possible experiments already there? By which I mean, that's all science is just a cascading by which I mean. By which I mean, are all the results predictable? If I had the time to do every experiment known to science, could I skip that and know the results ahead of time? Part of this is it's like loading distance in video games. You're closer than you think. Science is discovery, not invention. Schrodinger has left the chat, says Devam Johnny. Well, we're getting to all that. So when I ask these questions, I also am saying this. Is the universe local? By which I mean, are there events, observations, that can have no relativistic connection? Can events be separated? Can events that are linked to each other be separated by a distance such that for them to cause each other, it would have to happen faster than the speed of light? Because if the universe is non-local, where something on the other side of the universe could be affecting some system or observation on this side of the universe, then the ultimate predictability of experimentation, according to classical physics, is incorrect. Right? Hey, Kyle, shout out to my munchkins, Sophia and Savannah. Trying to get them to enjoy science much more, starting with you, says Bran Coslos with the 10. Bran, hey, Sophia. Hey, Savannah. I know I sound like a big nerdy guy with a lot of hair that you can braid if you want. It's fine. I get a lot of requests for that. I hope that you enjoy what you're watching, and that what I'm saying isn't too crazy or out there, but it is. And it's so crazy and so out there, very smart people won a giant prize for it. Okay, so as some of you who are reading ahead in the textbook are guessing, is that entanglement poses a problem to classical physics. I remember in high school hearing about how paired electrons can reverse each other's spins faster than the speed of light. Is this related to that? Yes. quantum entanglement poses an issue for classical physics. This is what you've heard as how Einstein didn't like spooky action at a distance. There is a way to create a quantum link between two objects, say a pair of photons and particles of light, and you can get one paired with another one, and they have different properties. You can quantum mechanics, the predictions of quantum mechanics say that you can separate these particles entangled by any distance, and if you make a measurement of one, you can immediately, instantaneously have an idea of the measurement of the other one. So if I take two particles, separate them by a distance of a galaxy, if I measure one and it has spin up, the other one I know will instantly be spin down, faster than the speed of light. Classical mechanics says that information can only travel as fast as the speed of light. And so, spooky action at a distance, Einstein didn't like this because it's challenged by quantum mechanics, which makes a lot of predictions. And, we start in 1935. Einstein and two other authors didn't like that quantum mechanics predicted non-locality. That events in the universe, observations could be made, things could happen that say this is happening faster than light, which challenges causality and all this stuff. Einstein didn't like that. So he proposed in a very famous paper in 1935 called the EPR paper, which is just the initials of the authors. He said that you're missing something. Because it would be so weird to have non-locality in the universe, to have FTL things going on in the universe. You must be missing something. You must be missing something in quantum mechanics. This missing stuff later went on to be called hidden variables. So this is what I was getting at the beginning, where I was saying, are all experiments known? Does everything have an outcome that could be predictable? Hidden variables is the argument that Einstein put up against spooky action, saying, well, if two things look like they're interacting faster than light, you must be missing something about quantum mechanics or the universe. There's some hidden variables here that do have predictable knowledge or predictable measurements that you aren't getting. Something that solves it. Quantum mechanics stuff, it's cool, but jump cut. Oh, don't do that. Jump cut to 1964, where a man named John Stuart Bell revisited this EPR paper, and he came up with what's now known as Bell's theorem, which is saying Bell's theorem says that the predictions of quantum mechanics are true and the universe is non-local. Basically saying that spooky action at a distance is real, is true. That is how the universe works. Now let's get too far. Let's get a little illustration. Is it possible to send data using quantum entanglement? No. We'll get to that. Now let's get a little illustration of this disagreement here. Who dat boy? Don't worry about it. So the top is the hidden variables argument. Einstein is saying, okay, it seems like you're getting spooky action at a distance. It seems like when person on the left gets a white ball, the person on the right immediately gets a black ball. But what you're missing is that information was always there. It was just hidden. We're not measuring it. We're not getting a good sense of it. The quantum mechanical interpretation is Schrodinger's cat, what you've always heard as the example. Instead of a black ball and a white ball in this illustration, they're gray. They're both simultaneously, and only when observers catch these balls, or you just look at them, That's only when they become black or white. Spin up, spin down, whatever variables you want. So that's the distinction here. Quantum mechanics says fundamentally unpredictable until you measure it. And then those measurements have some probability to them. Einstein said, no. Those measurements were always there. You're just looking at them and you're missing something about what happened before. Now we get even more complicated. Okay? Schrodinger's cat is so stupid. No cat in reality is alive or dead in the box, no matter if you measured it or not, says Jared Robinson. Well, Jared, you're taking a macroscopic thing too seriously. In reality, we're talking about the behavior of, nanoscopic environments at which quantum effects can be observed. When you scale something up to the size of you or me, all of this quantum weirdness cancels out. And so, no, a cat will never be simultaneously dead or alive, but it's an analogy where a electron can simultaneously be spin up and spin down before you measure it. Really. See, now what you're saying is hidden information, right? The cat has to be either dead or alive, and then we just see it, right? Quantum mechanics says, no, it is both, fundamentally. So now we get a little bit more complicated. I know it's already been complicated, but we get a little bit more complicated, okay? So to get a little bit more complicated, this Bell guy that we're talking about, and Bell's theorem, saying that the universe is non-local, stuff can happen, spooky action at a distance, he said that just mathematically, if you have two outcomes and there's hidden information, the two outcomes can only be correlated so well, right? You can't have 100% knowledge of what is going to happen with the observations if there's some hidden information that you're missing, right? Yeah. This is called a Bell's inequality. And I only mention that because we're going to say it as a term in a second. But these Bell inequalities get up to you can get 55% probability or whatever, 50% knowability of what these measurements are going to be, but no more because there's some hidden information. Okay? Okay. So what Bell is saying is that quantum mechanics really does break two things in traditional mechanics. That spooky action at a distance can happen, and that these measurements will be correlated as though there is no hidden information. They will know more. You can know more and predict more. Instead of being only 55% accurate, you can be 85% accurate, whatever. Not 100% again, but 85, much more accurate. Which is getting closer to, if we can predict this quantum mechanical system better than you think with hidden variables, then it's much more likely that quantum mechanics, quantum weirdness, quantum randomness is true. But John Stuart Bell in 1964, he had these ideas, but he couldn't prove it. Enter these boys. These boys, I closed out all of my tabs because I wanted to cut down on streaming stuff, so I forget their names off the top of my head. The names are... So, in the middle, we have Alain Aspect, John Clauser on the left, and Anton Zeilinger on the right. And what these men did, spoiler alert, is prove that the quantum mechanical interpretation of the universe is true. So in the 1970s and 1980s, these men, working together and independently and with PhD students and all of that, they developed some clever experiments that could, I know, nice stash he's got, huh? That could prove Bell's theory, that could show the universe is non-local, that could show correlations above a Bell inequality. How do they do that? Kind of like this. So, what Clauser first did is create a system, or he shined something on a, calcium atom that created an entangled pair of photons, like we were talking about, right? And then thousands of times, he sent these photons through filters, polarizers, basically just grates that light can or cannot go through depending on how that light is oriented. It's why your sunglasses will, if you turn polarized sunglasses in your car while you're looking at your dashboard, if you turn them 90 degrees, you won't be able to see your dashboard anymore. Because dashboard light is polarized such that polarized light can go through same direction. That's why polarized sunglasses cut down on glare. Because glare is coming all these different directions at your face, but you have sunglasses that only accept one direction, like mail through a mail slot, and it cuts out a lot of that light. Hey Kyle, I love you, says Dave Chongle. Now, what John Clauser found was that if you send this pair through two different polarizers, one outcome immediately determines the other outcome with a probability above a Bell inequality. So right there, he shows what Bell was saying. But physicists didn't stop there. Alain Aspect, he went even further because physicists weren't satisfied, and Einstein wouldn't be satisfied. He said, physicists at large said, well, okay, that's cool, but you were missing most of the photons, and how could you ensure that the actual measurement wasn't being influenced by you? What if you could have set up the measurements as to be random and just told us? So physicist Alain Aspect went further. What did he do in the second image here? He got even more, he had polarizers. He separated these polarizers by a distance that if you get information from both ends, that information will get to you faster than they could interact. Like if you separate these particles far enough and they change simultaneously or nearly simultaneously, if that distance is longer than light can travel in that distance, then it happens FTL. So now, polarizers separated to demonstrate FTL, faster than light. And then these little toggles right there that had switches that could change the polarizer. Okay? So going even further, they're like, okay, fine. We'll separate them so you can demonstrate conclusively FTL, spooky action at a distance. And once I hit the experiment, it's just going to start moving randomly. And I'm not going to be able to influence that. And again, they showed that the universe is seemingly non-local. That measurements were correlated higher than you'd expect, and these were happening faster than light. But physicists still weren't satisfied. They're like, okay, well, that's pretty cool, and you measured more photons and stuff like that, but how can we, you're still doing this like in a lab. How can we really, really, really be sure? Well, that's where Anton comes in. Anton said, fine. You know what I'm going to do? I'm going to use a crystal. I'm going to shine a laser on that crystal, and that's going to create pairs of entangled photons. I am then going to use random number generators to shift these polarizers randomly such that I can't even It's completely mathematically random. And then I'm going to activate the experiment by using signals from galaxies on the other side of the universe. Practically, thoroughly demonstrating that I could not influence this measurement. It is being kicked off from two different sides of the universe and then going through a random number generator. I'm not doing it. I can't influence it. And at a distance, that would be FTL. And guess what they all found? Together, these three men came up with and developed and executed incredibly complicated and complex experiments that couldn't have been done until they were in the 70s. You know, they were thought up earlier, and it was argued about even earlier than that in the 30s with Einstein. They came up with these experiments to show that Bell inequalities were violated, in that these two spooky action things are too connected to have anything missing, to have hidden variables. And these things were happening faster than the speed of light, which shows that the predictions of quantum mechanics say that stuff is happening in the universe that does not have prior cause, like does not have predictable prior cause or prior information or values, and it's happening faster than causality. What? So, returning back to our question that we started with, does color exist when you're not looking at it? Is it perhaps every color or no color until you observe it? Now, again, we were kind of doing a Schrodinger's cat thing there where it's not perfect, where we're talking about quantum systems and not macroscopic things, but the implication is the same. It's saying the universe does not work classically mechanically. It works in a quantum way, which is fundamentally different than what you'd expect. And that's important. Now, I should say that I know this all just sounds spooky, but it is practical. Because now, using the insights from quantum mechanics, we are going on to make inroads into quantum technology, quantum computers. We can do quantum teleportation, which isn't the transmission of information. That's theoretically impossible. But the transmission of quantum states across distance. I feel blunted and I'm sober. Not just quantum, I mean, the quantum mechanics makes the most accurate predictions in all of science. The first quantum revolution gave us transistors and laser beams, which are a part of every technology that you use. So these three science chads did three critical, groundbreaking experiments to prove that the universe works in this bizarre way. But I want to hear what you think about it. Pookie Bear with the 10 says, "Hey Thor, if I wrapped a rope around the world and held each end and pulled on one end, would I feel the pull instantly or would it be severely delayed? This has been driving me crazy. Also, I love you." It would be delayed. Because because there's some tug in the rope, right? It's going to stretch a little bit. And that the information of something moving or something changing in a material can only travel at the speed of sound in that material. So, for example, if you had a very long bridge, and you cut one end, you know that the whole thing doesn't drop instantly. You know that it goes in an arc, right? Because the information that it's no longer under tension travels through the object at the speed of sound in wood or steel or whatever. Same reason why a slinky, you can do this at home, kids. Get a slinky, look at the bottom, and then drop the top. The bottom will not start falling until the information that it is no longer under tension gets there. It's pretty cool. I feel like I said something there incorrect, but yeah, who cares? Can we all take a moment to to appreciate chat? Ugh, such a headache today. Can we please take a moment to appreciate Kyle's chat monitoring guy? It's a guy and a gal, for your information. And yes, I appreciate them. Yeez7 with the 999. Scientists finally figured out how the simulation works. Now I can work on finding exploits to improve any percent IRL glitches speedrun. Hey man, if you run your life like a video game, try to optimize, min-max, it's not going to turn out that bad for you, probably. And I still want to stress how weird it is that the universe acts non-locally. That messes up. I mean, it breaks classical mechanics. Right? If a ball can be hit by something before it was hit by something. See what I'm getting at? Causality doesn't lock faster than light because information travels at the speed of light. Justin Studer. Did I get that across? That was a hard conversation to have, and I'm not all here today. Justin Studer with a 10. On the smallest possible quantum scale, how does motion work? Do the particles just appear and then disappear in different places from one instant to the next? I don't know. I'm not a quantum physicist. But also, motion on a quantum scale might not make sense. Do you know what I mean? FTL information is not possible even with entanglement, Matt asked the question. So there's a no communication theorem that says you can't transmit any information using quantum entanglement because you're trying to send a text file across the universe faster than the speed of light to observe the information and send it. You break entanglement when you observe it. It's called collapsing the wave function. And that also destroys any information contained there. And so what you can do, which Zeilinger also did experiments with, one of the Nobel Prize winners today, is quantum teleportation, which is moving a quantum state. So, say, taking a quantum state, you have two entangled particles, one particle then hits a third particle, and that third particle is now entangled with the second. So it's kind of like, you know how optical cables work, how we need, as we send information through optical cables, if it's a very long cable, we need boosters along the way that, re-amplifies the light a little bit. This is kind of like what you do with quantum teleportation or moving quantum systems around, where an entangled system, it's very delicate. Hey Z, I see you. It's very delicate, so across distance, as you're separating these particles, you might want to instead have that third particle interact with it, so then you can basically start over, right? So it's creating new, you're transferring this quantum information, or quantum state, particle, particle, particle. So you don't have to take two particles, or whatever the system is, kilometers, miles, light years apart. Z with the $200 donation. Hello, Kyle. I've missed so many live streams. Also, I am sad because you have missed me PM on Patreon. Oh, I've missed you? I missed your private message on Patreon? I'll look you up, Z. Z, if you don't know, Z is a wild person. Okay, I got it right here, buddy. Ooh, it's a long question. I will get to that, Z. Z, thank you. Z is a wild person. Z wakes up every day, puts on a leather jacket, no pants, gets on a Ducati Superbike, jumps on, instant rev, easy, because there's many people making sure so instantly down a private highway, much like they used in The Matrix 2. And then along the way, he likes to throw money at people and animals. And I'm one of them. Yeah, it's weird, but I don't make the rules. I just enforce them. Can you set up two quantum computers to run the opposite experiment instantaneously at the same time so you can know the opposite? I don't know. Can you set up two quantum computers to run the opposite experiment instantaneously at the same time since you can know the opposite? It says Ralph Mayans with the $9.99. The power of a quantum computer is running through an arbitrary or infinite or all possible states simultaneously. So what you've heard about quantum computers specifically is the qubit. That's what makes them powerful. Instead of a bit of information, it's a quantum bit. It's a qubit. And that, instead of a traditional 1 or a 0, it's 1 and 0 simultaneously, literally. And so, by having literal simultaneous states, you can easily, you can easily show how just a couple of qubits together can handle exponentially more and more and more operations. I think, you can have like 32 quantum bits, and what is 32? Because each one is a superposition, right? Superposition of a 1 and a 0. So it's like having where is it? Yeah, so it's like having 2 to the n power, right? So I'm looking at here that So if we're talking about a quantum computer, imagine that it has RAM, and that memory is represented by qubits and how many operations they can make with their 1s and 0s. 23 qubits, and you get 1 megabyte of RAM. Okay. 33 qubits, and you get 1 gigabyte of RAM. 60 qubits, and you get 1 exabyte of RAM. I'm talking about bits, less than 100 qubits, and you're talking about petabytes to terabytes to exabytes of processing power. I know that didn't answer your question, but I forgot your question. Hey, Kyle, love your work, says Mr. Pixelator with the 10. I'm not very good at understanding this kind of stuff, so this might sound dumb, but would it be possible for quantum events to be linked through a separate plane? Now, I'm not sure what you mean by plane, whether you're talking about like a geometric plane, just like on a different axes or something like that. Oh, are you talking about just not separated by, a horizontal or a vertical distance? As far as I know, yeah. Yeah, an exabyte of RAM. 63 qubits contain as much classical bits as an exabyte of data. By comparison, 63 traditional bits can only store 8 bytes. So there's that's the real power that we're getting at. 63 bits can store 8 letters. 63 qubits could store every movie ever made. Whoa, I caught a live stream for the first time ever, says Josh Maxwell, Raina Allen. Well, it's because you had so many names weighing you down, buddy. Anyway. I know there was a lot of quantum stuff. I hope that we kind of got across why this fundamental insight by the Nobel Prize winners was important. It proves the fundamental prediction of quantum mechanics, that the universe is not only weirder than we think, but maybe even weirder than we can think. Think about that. Well, that's the quantum thing I was looking at. Peer review. So as I'm wont to do in every episode of Office Hours, I like to go through what y'all said in the last episode of the facility and make one of you an honorary member for being so hey-ho-wow. Last episode of the facility was what? Don't look at my recommendations. Was the Basilisk. I had a refutation of the famous Rocco's Basilisk. It relied on some logical arguments and a weird version of the Prisoner's Dilemma. If you haven't watched it, go watch it. And if you want to watch something more after this, reminder, because it's spooky month, we will be jumping into Dead Space, maybe the best horror game ever made, right after this stream. Adam Frost with the New Zealand $17. Hey, Kyle, speaking about quantum I'm working on my Kiwi. Hey, Kyle, speaking about quantum computers, it's talked about how they will be able to break passwords, etc. Do they just know the answer using quantum magic, or are they processing really fast? Adam, they're processing really fast. So, like iPhone security right now, if you put, like I do, and you should, 6 numbers for your PIN to open your phone. With having just 6 numbers, it becomes practically impossible to brute force your phone, which is using another computer, another device, to try to crack your phone by giving your phone every single possible combination of those numbers. And because there's so many possible combinations, it would take years to crack your phone or whatever. And, of course, iPhones have different security where, if you do more than 10 attempts, it just wipes your phone or whatever. But what you're talking about with quantum computers and possibly destroying that aspect of security. G'day, handsome man, says Dan Boy. Oi. How you going, mate? Like I said, with a quantum computer with 63 qubits now has an exabyte of RAM to execute or whatever, RAM, memory, operations per second. It's so orders of magnitude bigger, larger, that what would take 100 years to crack with a normal computer suddenly becomes seconds, right? Just orders of from years to days to seconds or whatever. And the power of a quantum computer is that small number, that it will only take 63 bits to do that. And so with the anticipation being that quantum computers will get that big and bigger, like 1,000 bits, 1,000,000 bits, qubits, which is really hard to do. Again, quantum states are fragile, and we literally have to have entangled particles all kind of working together. When that day comes and we have hundreds or thousands of qubits in a quantum computer, it will be able to reduce brute force problems to trivial ones, right? If we were living in the simulation, what was the original Kyle Hill like? You don't think I'm based reality? I hear I'm based from the kids. Don't know if that's good or bad anymore. Last episode, we tried to refute the basilisk. You're running a Hamiltonian on that question as we speak. I'm running a I'm trying to find what their Lagrange is for it. Lagrangian. And I want to hear what you had to say, because the basilisk was... Can you hear how slow my brain is running today? I mean, you can hear that I'm not... May have had one too many old fashions while watching Beetlejuice. Holy shit, I can't. Coffee with the taste of Chernobyl, made with pine resin from trees in the zone. There's drugs for that, Kyle. Anyway. The basilisk was the first viral video we had on the channel. And so I wanted to do an update where some of you were legitimately worried. Most of you weren't, but some of you were. And I want to see what a refutation of the basilisk in the first place. What do you think about that? Z again. With the $50 donation to expand on this brute force problem, what about P versus NP? Would a solution to that also make brute force trivial? I know what you're talking about, but I'm not an expert in that kind of stuff. I have no idea. Cringe is negative, says Brandon Scales. Rackneth says, your content is aimed at minors. This elementary stuff is fun, but it's not all that mind-blowing. Says, smartest man in the continental 48 states, Rackneth. Well, I never said anything that I'm doing is revolutionary. Just interesting. Hey, but, you're here, aren't you? Anyway, what if there is a counter basilisk to prevent the basilisk from being created? And so it will torture everyone who is working on building the basilisk. If you don't help build the basilisk, you run the risk of being tortured by it. However, if you do help build it, you run the risk of being tortured by the counter basilisk. What do you think about that? The thought experiment itself doesn't bother me much, but as someone who has a child was terrified of the basilisk in Harry Potter. Oh, your renders and graphics of the basilisk are both brilliant and terrifying. Yes. We had we had many meetings back and forth at the facility on how, if we were going to make our own basilisk, it may as well be scary, right? You can unhide Rachna. I'm fun. No. You Crafty. You can. No. Nobody pile on Rachna. I appreciate criticism. It's fine. It's fine. It's fine. It's really fine. Criticism is good. We do have Basilisk merch. It's on an old store. It's a Redbubble store. Maybe Crafty if you have it. But we do have t-shirts with the Basilisk, and I do have really cool Basilisk stickers too. One's on my machine right here. That's running all of this. Running all this. But kind of back to that point. It's oh no, now only I can do that? All right, I'll undo it. Let me undo it. Rachna, I want to get you back here. Oh, you're gone. Wait. As a European, I'm automatically smarter than Americans. Says Rachna. Yeah, maybe you can be hidden for a second. No, but criticism is good. And I want to know if what I'm doing is not sufficient. If my content is not for you, that's fine. But to be fair, I'm not an expert in anything. How could I give mind-blowing, cutting-edge, ultra-scientific lectures without even being a working scientist? My goal is to create more of those people who can give you the kind of mind-blowing science that you need, Rachna. I'm too old. And my mind it's not great. I want to be the teacher, the good teacher that people didn't get. That's all. That's all. I mean, I have a... Whatever. It's fine. It's fine. Am I doing mind-blowingly good communication? Because I have appeared in a couple of PhD theses. So, eh? When I was a little girl, I had a pair of ChromaDepth 3D glasses that gave an illusion of depth based on color. What? Red was nearest, blue was the furthest, and every other color was in between. I was so enamored with them that I wore them for 2 weeks, only removing them to sleep or bathe. It's been... Oh no. I see where this is going. It's been 20 years since I lost those glasses, and my brain still interprets any red image as floating above the image, and as blue as being sunken into the image, says Sadie System. Thor Nerdasun, says Kinemania. I'm going to steal that. Kyle, please read this comment, says Aaron Ronan. No. Hey, Platinum. Hey, boss, they're saying you revealed my face, says Kevin. Yeah, you're in the latest episode. Sadie, I have never heard of that before. So I did talk about an info hazard that's similar in the episode. But for you to have lingering effects of wearing glasses, I mean, I guess it was during your formative years and when your brain was still, growing and stuff like that, developing, rather. To have a lingering what is this word? An almost synesthete. Jesus. An almost synesthete-like experience 20 years later, Sadie. I gotta make you an honorary member of the facility because I've never heard anything like that. What I have heard of is coffee, because I don't know if I'm gonna make it, everybody. Said if there's all these Kevins, wait, how many Jareds are they? Jareds are not allowed in the facility. We have a long-standing beef with Jareds. Who made this? Says Guitar Hero Man, a very talented artist on Twitter and Instagram. I'd have to look it up. It was like over a year ago. Made that incredible anime Giga Chad Kyle, and I had a Magic the Gathering playmat made of it, and I have card sleeves. It's just awesome. How can I become an info hazard, says Logan Stewart. Make knowledge of your life a risk to people. Make knowledge of where you are a risk to people. This is going to be my most rewatched stream, says Think of Fur. I really hope I got most of that right. I think I did. I did a lot of reading. I mean, I had a notebook. I did a lot of reading beforehand, so I think I got most of that right. But it's the non-locality stuff and establishing the basic predictions of quantum mechanics as opposed to what Einstein would have said. Classical relativistic mechanics. Kyle, you've helped me a lot, says Dustin Lee Bladesmith. You're a great inspiration. I feel like I could talk to you for hours about our shared interests. Maybe someday we'll have a collaboration of the minds. That would be very nice, Dustin. Once, once the cons and stuff pick back up again, we'll get out there. Probably not Comic-Con again, unless I'm doing some sort of panel, because that's so many people. But I was just at Adam Savage's convention, and that was great. I am now Spider-Blood has already changed their avatar image in the chat because it's awesome. I think Kyle just told that guy to become a serial killer, says Chase B. I'm not saying become dangerous. Like, I'm not saying you should become a dangerous person. I'm saying if you want to become an info hazard by definition, it should be hazardous to know about you. I mean, so you can define an info hazard not just as like, killing a person. It could just be some psychological detriment. Stress and etc. I'm 100% confident that there are many of those kinds of info hazards that, say, doctors have. That there are many things that doctors intentionally don't tell us to save us some psychological harm, right? One I can think of off the top of my head, it's not a bad one or anything, but is MRIs it's a nuclear effect. They're like the amount of radiation used in medicine is not something that is focused on because they don't want to scare people, because even though it is safe, or safe enough, depending on the treatment, they don't want to cause undue psychological harm. That's an info hazard in and of itself. Militaries have that kind of thing, I'm sure. They don't tell you what really happens on the front lines until you get there, or see something, or you go on Reddit and you see something you really didn't want to see yesterday. Hey Kyle, I'm in middle school and you've taught me so much about nuclear power. You've inspired me to learn all I can. I'm certain it'll be my profession, and thank you, lovely lady. That is the best praise I can get. You sound lovely. Look, all I want to do, even if there's a bunch of smart Europeans in the chat who think that I'm just talking about baby stuff here, all I want to do is try to be a conduit and share with you what I find interesting, and hope to usher you into things that you find interesting too. So, if that's nuclear energy for you, good on you. It will be needed in the future, trust me. If my GPS location was a nuclear launch code, I would be an info hazard, says Basil. See? There you go. Captain Dagan says, I almost missed the stream. Well, we're about to start the next stream. Look, chat, as I prefaced at the beginning of the stream, having a hard brain day today, but what did we go through? We talked about what won the Nobel Prize in Physics this morning. Pioneering, brilliant experiments by 3 different researchers and their teams, proving that the underpinnings of quantum mechanics is true, that the universe can act non-locally, around causality. That quantum mechanics is indeed weird. And these pioneering experiments have led and will lead to new inroads in quantum information technologies, etc., etc. We've also taken your comments and questions. We learned that somebody wore glasses for too long as a kid and now sees stuff weird. But don't worry. If you want more science, if you want more of me not being all here today, 30 minutes from now, right after this stream ends, you can either go to the Kyle Hill Gaming channel, or you'll be automatically directed from this stream to the gaming channel, and we will begin our spooky month science streams, where we play great video games and we talk about the science therein as we do so. It's Dead Space 2, one of my favorite, well, my favorite horror game, surely, but one of my favorite games. I cannot wait to see you there if you want to join me, but if not there, coming up this week in the facility, I'll tell you the story, the amazing true story and ongoing story of the puppies and dogs of Chernobyl, possibly the most unique dog breed in history, and how you can help them. We here at the facility will make a dent in the problems that I will show you, or not. So, no matter where I see you next, if it's on the next live stream, if it's next week, if it's in the facility Discord, which you can join at Kyle Hill, Patreon. It's in the chat. Until then, be nice to each other, because this is all we got. I'll see you in a couple minutes.